All right, today I'm going to go through lesson 3-1, relations and functions. I'm starting on page 94. All right, so the first thing we want to do is just recognize what domain and range are. So remember, domain is going to be your x values and range is your y values. So you're just going to list these in order from smallest to greatest. So for this first one, they're already smallest to greatest. So your domain is 2, 3, 4, 5, and 6. And your range is your y values, 0, 1, 2, 3, and 4. Because they gave you these specific coordinates, those are the only points that count in your domain and range. If it was a linear equation, then like 2, 2.5, 2 3/4 would all also be valid. So then it would be like 2 through 6. Like if the line went from 2 and then stopped at 6, like they made a line segment or something. Or if it was linear, like going on both directions, like then my x and my y go on forever. Okay, those are all different circumstances though. When they give you specific coordinates, only those coordinates are listed in your domain and range. Okay, so then we've got -3, -1, 1, 3, and 4. And those are also in order already. Then these are out of order, so I'm just going to put them in order. -2, 1, 2, 3, and 6. So you're not putting them like where they match. You're putting them in order from smallest to biggest. All right, the next one says analyze reasonable domains and ranges. We're looking at like what are the constraints on our domain and range. So a bowler pays $2.75 per game. So each game costs $2.75. So you're looking at domain as being like number of games. Okay, because maybe we say it's 2.75 times x. Y equals 275x. Because it's $2.75 per game. You multiply it by how many games, and that gives you your total. So my range, my y values, are going to be total cost based on however many games. So maybe, you know he can't play like -1 games. He could play 1 game. Or maybe he played 0 games. If he played 0 games, how much does it cost? If he plays 1 game, how much does it cost? 2, 3. Maybe he could play 4 or 5 games in a day, but that's probably about it. I doubt somebody's going to play 10 games in a day, but maybe you went up to 10 or something like that. It's not going to be 100. And then the range is the cost. And that's $2.75 for every game. You can't play a half a game, so we're not talking about a linear equation here. So whole games, and then you take that and multiply it by 275 to get your range. So 0 times 275 is 0, because he plays no games. It didn't cost him anything. Then 275 for 1 game, 550 for 2. 3, we're going to add 275 again, and you get 6, 7, 8 1/4. Add 275 again, you get 9, 10, 11. And I think that's it. 0, 1, 2, 3, and 4. Yeah. So your answer might not be exactly the same as mine, but if you know you're not going to have any negatives, you know you're not going to have any really high numbers. Okay, a car travels 25 miles using 1 gallon of gas. So every gallon of gas, they travel 25 miles. So you're going to take the y equals 25x. Here's 25 miles for every gallon. And that'll tell you how many total miles. So if they use 1 gallon, they went 25 miles. If they use 2 gallons, you multiply it by 25 and you get 50 miles. Okay, so I'm gonna write this a little further down so I've got room. So domain is my gallons of gas. My range is my total miles. Okay, and a car can hold maybe 15 or 20, maybe 25 gallons of gas. I think mine holds 16 or 17. So your gallons is going to start at 0 and then maybe go 1, 2 until you get to maybe 20. And then my range is going to be those numbers times 25 to give me my total miles. So 0, 25, 50, so on. And at 20 gallons, 20 times 25 will give me 500. 10 times 25 is 250, so 20 times 25 is 500. So we're going to go to 500 miles if I use the whole tank of gas. So the next one we're doing, when we have a relation, we're saying that there's a relationship between these numbers and these numbers. If it's a function, hi Jack. If it's a function, then each x only goes to one y value. And in this one, we have an x of 3, and then y comes out as 6, x of 3, y comes out as 7. Not a function. Oh my goodness. Jack's being ridiculous. Not a function. 1x to 2 y's. And that's right here. Stop eating my lamp. Are you crazy? Look at that face. I wonder how things get messed up. Okay, then we want to see if this is a function. Are linear equations functions? Think about it this way. If I drew a straight line, remember your vertical line test? I'm only going to hit 1 point. So every x only has 1 y. So this is a function. All right, now we're going to look at constraints on the domain. So that's kind of the same thing as when we're analyzing a reasonable domain. What are constraints? Things that can like stop your domain from going to the left or to the right. Margaret has a monthly clothes budget of $50. She maps the amount of money she spends each month to the number of items of clothing she buys. What constraints are there on the domain? So we have the amount of money is her x. Each month to the number of items of clothing she buys. So what constraints are there on the domain? So her budget is $50. So she's not going to spend negative. No negatives. And can't be more than $50. That's it.